So hi, this is Kiwi. So in the previous presentation, I present with an research paper. So for this second one, I would like to present one recent published review paper with the title "From Lab to Wearables: Innovations in Multifunctional Hydrogel Chemistry for Next Generation Bioelectronic Devices." So actually, I wrote this and published within this year in 2024. So actually, this review paper provides a comprehensive exploration of functional hydrogel and also emphasize the critical role in advancing biowearable technologies. So here shows the motivation and highlight part. So as you know, hydrogels has its really unique properties, including different kind of hydrogel stimuli responsive, self-healing, conductive, adhesive, unstretchable, and other different kind of multifunctional as well. So and why we're choosing this one, we like to position them as an essential materials for perfectly biological integration and durable performance. So you can see it how can it applies on human and with in terms of the biowearable device application, for example, like chemical biosensors, physical biosensors, or some other wearable devices, drug delivery, and so on. So this review highlights the application on just what I've mentioned here, and it also underscores the path to commercialization, focusing on the translation lab scale hydrogel innovative into critical scalable solution with some uh, user design that prioritize biocompatibility and mechanical durability. So actually this work you can see is kind of interdisciplinary perspective, combining insight from material science. And also here you can see is the biomedical engineering and wearable technology. So we want to show how the important hydrogel's functionality and with its versatility and application design. So and also but addressing existing challenge, for example, some limited conductivity and mechanical strength. So this review outlines the strategies for creating multifunctional hydrogel tailored to specific healthcare needs. So this review begins with a historical timeline for the development. So in short, you can see the timeline begins with a really basic biomedical uses, such as contact lenses. And you can see here, contact lenses and drug delivery system before 2000s. So the focus then shifts into integrating conductive hydrogels in the early 20s here, and shown here. So it enabled signal transmission for bioelectronics. By the 2010, you can see the development shows here the self-healing hydrogel with reversible bond uh emerged, addressing the durability challenges in wearable devices. So in nowadays, two tools, the stretchable and tough hydrogels also features in many different kind of applications. So you can see the overall evolutions for the development of the hydrogel with respect to their applications. So it's actually is really important to bridge functional hydrogel between the biological systems and the wearable electronics in terms of biocompatibility, electrical conductivity, and tunable mechanical properties. So actually the synergy of this biological compatibility and electronic functionality, so it positions hydrogels as a really superior alternative to traditional elastomer materials. So they are all interrelated. So the first one, uh, So actually, we're not going into really detail, but we'll just show the first one we introduced different kind of stimuli responsive hydrogel. So here you can see it can be like categorized in physical, biological, and chemical with different like pH, protein, DNA, temperature, and so on. And also like here shows each of them with their respective example here from figure B to figure F here. And also for functional hydrogels in wearable electronics, besides those responsive trigger hydrogel, there's other type of functional hydrogels. For example, the conductive hydrogel, self-healing hydrogel, and stretchable and tough hydrogel, adhesive hydrogel. So actually, you can see there's different kind of categories and groupings for this hydrogel with their own functionalities and usage here. And here shows all of the example respectively. And usually like they would be mixed into multifunctional one. So but separately you can see they have their own unique function here for each application. So after introducing the chemistry and the I mean in terms of the materials, so we're going kicking off to the usage of this hydrogel in terms of application. So first of all, we have like separate it into biofluidic biomarkers monitoring. So for example, hydrogel can be used in various applications. For instance, ISF monitoring with using like microneedle patches for glucose or lactase detection. And also even it can be used to test and or sense and monitor sweat, and as well as tears, like contact lens with like photonic hydrogels for glucose sensing. So we have summarized this in terms of the biofluidic biomarkers. And also like um wound management. So actually wound management is a really big topic which can be uh commonly being analysis by hydrogel monitoring. For example, like we can use hydrogel to monitor the wound pH monitoring. pH responsive dressing indicate like infection or healing stages. And also like temperature responsive dressing as well. And finally, like gas biomarker sensing. Sometimes there's like hydrogel materials involved of in the fabrication for this kind of like gas sensor to measure like for example CO2 and H3 detection in breath. Yeah, usually using like respiratory health and environmental monitoring. And also in the perspective of electrophysiological signal monitoring, so you know like really common ones will be the ECG, MNG, and EEG signal capture. So most of these kind of electrodes are uh, being utilized by the hydrogels, and also like flexible and adhesive hydrogels usually also being utilized for to ensure the durability and comfort. So their applications will be really range, for example, for emotion recognition, muscle activity monitoring, and portable cardio diagnostic. Um, Also like they can be used in like physical motion sensing, like joint or blanking, or in string sensors, or even in organ activity monitoring like lungs, and intraocular pressure. And finally, it's always been easily been seen. It applies on the drug delivery. So yeah. So this is the end for this presentation. Thank you.